Hello everyone, in this video I'm going to discuss the example for limits and continuity. Given that we have the function fx, so rewrite the situation. We have 3x plus the 5 over, can we factorize the situation, x minus 1, x minus 2. Find the horizontal and the vertical asymptote, if any. So refers to the function. First what we have to do is to find the domain. So as we can see in here, we have all real number. Then as for the denominator, x cannot be 1, x cannot be 2. So the domain for the f would be negative infinity until the 1, union 1 until the 2, union 2 until infinity, where the 1 and 2 is not included. So that is the domain. Second step, find the vertical asymptote. So we have to refer to the domain, limit when x approaching 1 from the left, limit when x approaching 1 from the right. Limit when x approaching 2 from the left, limit when x approaching 2 from the right. So kindly copy the function fx. So kindly refers to the real number line in here. Focus on the 1 and also the 2. So for the left hand side, we have 0.9999. Then on the right, 1.0001. Same goes to the 2. We have 1.9999, 2.0001. So let's substitute into the situation. 1 from the left. So meaning that we are going to substitute 0.9999. So if we focus on this part, we will have a positive value. If we focus on this part, we will have a negative value. If we focus on this part, we will have a negative value as well. So based on the situation, we have the positive infinity as x approaching 1 from the left. Next, focus on 1.0001. If we substitute in here, we will have a positive. If we substitute in here, we will have a positive. If we substitute in this part, and we will have a negative. So as a conclusion, negative infinity as x approaching 1 from the right. Next, substitute the 1.9999 because x approaching 2 from the left. If we substitute this part, and we will have a positive. If we substitute this part, and we will have a positive. If we substitute on this part, and we will have a negative. So, conclusion, negative infinity as x approaching 2 from the left. Finally, we have 2.0001. So for this part, definitely we will have a positive. Same goes to this part, positive. For this part also, positive. So we will have a positive infinity. So from here, we can make a conclusion. Vertical asymptote are x is equals to 1, x is equals to 2. Next, focus on the number 3, horizontal asymptote. Limit when x approaching negative infinity. For the function, we have the 3x plus with the 5 over, we have the x squared minus 3x plus with the 2. So if we substitute, and we will have the indeterminate form. So from here, the strategy will be dividing the numerator and also the denominator by the highest power of x by referring to the denominator, the highest power, where we have the x squared. So meaning that limit when x approaching negative infinity, can we factor out the x squared? So here we have the 3 over x plus with the 5 over x squared over, we have x squared 1 minus 3 over x plus with 2 over x squared. Can we simplify? Limit when x approaching negative infinity, we have 3 over x plus with 5 over x squared over 1 minus 3 over x plus 2 over x squared. So if we substitute the negative infinity into this part, we will have 0. So as a conclusion, we have 0 over 1 where we have 0. Limit when x approaching positive infinity. Since we're having the same situation, so my advice is just to fill up with this part. So we can see we have 0 as well. So horizontal asymptote is y equals to 0. So here we have one horizontal asymptote, y equals to 0. Vertical asymptote, we have x equals to 1, x equals to 2. Next, we have the function of g is defined by the gx. So my suggestion would be illustrate the situation in a real number line. So focus on this part, we have value 3 and also the value 9. For this one, we have x less than equals to 3. So we have 9 minus a squared. Next, we have 3 until 9, where we have the function 3 minus x over, we have 3 minus square root of 3x. Next, we have x greater than 9. Focus on the modulus x minus 9. Define the situation where x minus 9, negative bracket x minus 9. X minus 9 greater equals to 0. X minus 9 less than 0. So kindly simplify. So we have modulus x minus 9 equals to x minus 9 negative x minus 9 with the domain x greater equals to 9, x less than 9. So focus on this part, dimension x greater than 9. So meaning that we are going to make use of this part. So kindly substitute the function. So in here we have x minus the 9 over 9 minus the x plus with the b. So continue. Where we have the a and b are constant, find the value of. So number 1, find the value a if limit when x approaching 3 for the function gx exists. So meaning that we have limit when x approaching 3 from the left is the same for the situation limit when x approaching 3 from the right. By referring to the real number line, kindly substitute the function. So here we have 9 minus a squared. 3 minus x over 3 minus the square root of 3x. So kindly focus on the left. So if we substitute the 3, so we will have 9 minus a squared. Focus on the right hand side. So if we substitute, we will have the indeterminate form. So in here we have 3 strategies. Number 1, multiply by the conjugate. Number 2, factorize the situation. Number 3, by using the long division. For this question, my suggestion would be multiply by the conjugate. So where we have 3 plus with the square root of 3x. So do remember, expand only one part. So for this case, focus on the denominator by using the formula a squared minus b squared. So rewrite the situation. Limit when x approaching 3 from the right. So 3 minus x multiply with 3 plus with the square root of 3x. Over, making use of the formula. First, a squared, we have the 3. So we have the 9. Minus the b squared. b, we have the square root of 3x. If it's square, we will have negative bracket 3x. So kindly simplify the situation. Limit when x approaching 3 from the right. So 3 minus x bracket 3 plus with the square root of 3x over. Kindly factor out the 3. So we will have 3 minus the x. So notice that we have the common terms. So kindly simplify. So we have 9 minus a squared equals to limit when x approaching 3 from the right, 3 plus with the square root of 3x over the 3. So if we substitute the 3, then in here we will have square root of 9, which is equals to 3. So 3 plus with the 3, we have 6 over the 3. So we have the value 2 for the right hand side. So 9 minus a squared. So based on the situation, so we have the a squared, which is equals to 7. So a will be equals to square root of 7. A will be equals to negative square root of 7. Next, focus on the second part. Find the value b if the gx is discontinuous at x is equals to 9. Limit when x approaching 9 from the left is not the same. Limit when x approaching 9 from the right because of the discontinuous. So meaning that the limit when x approaching 9 does not exist. Kindly substitute. We have 3 minus the x over 3 minus the square root of 3x. Continue. We have x minus 9 over 9 minus x plus with the b. So focus on the left hand side. If we substitute the 9, then we will have negative 6 over, if we substitute the 9 in this part, so we have 3 minus the square root of 27. So if you rewrite the situation, we have the negative 6 over 3 minus 3 square root of 3. Kindly simplify the situation. So negative 6 over the 3 bracket 1 minus the square root of 3. Then we can write negative 2 over 1 minus square root of 3. Multiply by the conjugate. 1 plus with the square root of 3, 1 plus with the square root of 3. So we have negative 2 bracket 1 plus with the square root of 3 over. So we have 1 minus the 3, which is equals to negative 2. Then finally we have 1 plus with the square root of 3 for the left hand side. focus on the right hand side. Kindly substitute the 9. Then we will have this part, 9 minus 9, 0. 9 minus 9, 0. So which is indeterminate form. So what we have to do, in here we have 3 strategy. Number 1, multiply by the conjugate. Number 2, factorize the situation. Number 3, long division. So my suggestion would be making use of the factorization. So limit when x approaching 9 from the right. Factor the negative and we will have 9 minus x over 9 minus x plus with the b. So notice that we have the common terms. So kindly rewrite the situation. So limit when x approaching 9 from the right. We have the negative 1 plus with the b. So refers to the situation. For the left hand side, we have 1 plus with the square root of 3. Then for the right hand side, we have negative 1 plus with the b. Rewrite the situation. So b cannot be equals to, we have 2 plus with the square root of 3. So meaning that they cannot substitute 2 plus with the square root of 3. Then the value for b would be negative infinity until 2 plus with the square root of 3 union 2 plus with the square root of 3 until infinity. That would be the suitable value for b in order to make the situation gx is discontinuous at x is equals to 9. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.